Hello and welcome to the Applied Deep Learning course 2023 at the TU Wien. In this course, you're going to learn a lot about machine learning and more specifically about deep learning and how you can use this technology to solve challenging tasks that just a few years ago have been considered extremely hard to solve. My name is Alexander Pacher and I will be your instructor for this year's edition. Before we start, I would like to introduce myself with a few words. I'm working as a software architect for the Berlin-based startup eNote, where we're trying to build an intelligent sheet music app which tries to bring sheet music into the 21st century. I'm also a musician myself. I'm singing in the a cappella ensemble Roots and Roots, as well as in the TU Wien choir. A few years ago, I completed a PhD in the field of optical music recognition, where I tried to teach the computer how to go from an image of music scores into something that a computer can actually understand. And throughout my PhD, I worked a lot with deep learning, and I thought, after I completed my studies, that the knowledge that I've gained was actually really valuable, and I'm here to share this knowledge with you. You're probably here because you've read deep learning and you thought, woohoo, I want to learn more about this, and you're definitely not alone with this sentiment. So when I started this course in 2018, deep learning was at the peak of inflated expectations. So here in this Gartner Hype Cycle 2018, you can see it at the top. So a lot of people were really hyped about this topic, and this actually has not changed in the last couple of years. 2 years into the future, 2020, you can see here 10 different topics from the area of AI and machine learning, and more specifically deep learning, appearing here, like explainable AI or some generative AI. And even last year, you can still see that some of the AI topics appear in this Gartner Hype Cycle, causal AI, machine learning, code generation, etc. So even though it might not be that hypey anymore, it is still an extremely exciting topic. And I hope that by the end of this course that you will not land in the trough of disillusionment, but actually understand what you can do with this technology. But speaking about inflated expectations, when I started this course, and sometimes when people talk about AI and machine learning, they have inflated expectations. And to me, it reminds me sometimes a little bit like this short clip where a journalist asks a researcher about CRISPR-Cas9, the gene scissors, and the potential applications of what you can do with it. Let's have a look.
Could CRISPR give us unicorns?
So, we're getting creative now. So there are examples of animals that have single horns in the middle. So like the rhinoceros has one at its nose, but there are other ancient rhinoceros that have it in the middle of the head. So anyway, I think that you could get a single horn on a horse by looking at horns in other species.
So it's in the realm of possibility?
Yes.
It's within the realm of possibilities. I think this sums it up very nicely. And when people talk about machine learning and AI these days, there is also a lot that is within the realm of possibilities, but not everything is realistic. And in reality, it's often that people that do not understand this technology are afraid of what it can do and what it might do to them. However, when people actually start working with this, the reality can look dramatically different sometimes. So the goals for this course, why you're here and what you should take away from this, is a basic understanding of what can and what cannot be done with deep learning. So I want you to gain hands-on experience with this technology and learn how to pull off a deep learning project, starting with collecting data, preparing the data, training some models, and ultimately showing to someone what you've done by learning how to present the results properly and deploying your application in such a way that anyone can understand what you've done. About this lecture, it's called Applied Deep Learning, and this applied part is actually really important because I expect you to actually do most of the work. And I believe the best way how you can actually learn something about the technology is by, getting your hands dirty, playing around with it, failing, learning from your failure and trying again and doing it better the next time. And this is why the whole lecture evolves around your project. There will be 3 assignments that should help you to structure your project. You will in the end present your results and also write and sum it up in a written report. And my part of this lecture is only to give you some theory that should help you to implement your project as much as possible. Given the fact that the field of deep learning is quite broad, I will try to cover many different areas. So your project might only be covered in a bit of a later lecture, but I hope that I will still kind of provide these videos early enough for you that you will be able to watch them and get some good information for your project as soon as possible. A few words about the project itself. As I said already, you should get your hands dirty, and I do not want to tell you what to do. I actually want you to pick a topic that you feel interested in. I want you to say, I always wanted to try to, teach the machine how to compose some music for me because I'm a DJ and I really like some of this electronic dance music. So you say, okay, this is my topic. And then you should pick the project type, which I will explain in a second. And the most important thing for me, and you can already start, bouncing off ideas and trying to understand this, is it should be something that is really interesting for you. It should be something that, you want to work on and that is useful for you in the end. So there are 4 project types that, again, should help you. And the boundaries between those project types is not always very strict, but it should give you some basic guidance. The first one would be bring your own data. So the main focus of this project type would be collecting data and making it useful for an existing machine learning approach. A good example would be you collect some images, you annotate them, and then you train an existing image classifier to perform a certain task on those images. The second project type would be bring your own method, where you take an existing data set. There are already a lot of data sets out there in the world that people have published. You can just take that data set and try to, tweak existing methods to such a way that it kind of becomes your method of machine learning here. You take some existing neural networks, you change certain parameters, play around with them, apply some of the things that we learned in this lecture to maybe make them more efficient, and then train it on this data set. The third one would be beat the classics, whereby I would you challenge the state of the art without machine learning by an algorithm or by a machine learning algorithm that tries to beat this baseline. For example, you could have a half-line detection to detect lines in an image, and then you say, okay, I believe I found a better way how to solve the same problem but with machine learning. And then you compare these two, and ideally you can show in the end, or you should be able to beat the baseline. And the last one would be called Beat the Stars. This category is the most challenging one, and I only recommend this for people that are maybe already doing a PhD, where you try to improve the state of the art. So you pick a data set and a an approach, a publicly available paper that shows how to solve this issue, and you try to beat that paper, kind of that state of the art. I understand nowadays that papers are being published extremely rapidly, and it's hard to keep up with papers being published every day. So it's fine if you take a certain baseline that is kind of up to date now, and you can freeze the state of the art for the next half of a year of this semester. But however, you should pick a topic and a paper that is up to date right now and try to beat that one. Grading works in the following way, that your project is kind of the way how I will grade you. So the mode would be called immanent, and you have 5 parts, the 3 assignments, the report and the presentation in the end, each one being worth 10 points. And the criteria by which I will grade you is obviously the result, although I want to mention that if you put yourself into a position where you have an extremely challenging task and you do not achieve that, but I see that your approach and everything was fine, I will not kind of deduce points for that. So failure is acceptable, but not, trying something not really and then just not getting any results. This would not be acceptable. I also would like to award you for creativity and complexity. So if you come up with a really nice idea, I think that's really interesting also for me to see how you try to solve that problem. I'm also always learning a lot about different approaches and different methods as I'm teaching this course. And given that we're in the computer science department, I will definitely have a look at your code and also grade that. So please make sure that your code is in good shape. And what I mean by that is that you adhere to the standard principles of software development, meaning that you use proper variable names, that you provide some documentation, that you structure your code in a way that is readable and understandable, not only to me, but also to yourself if you ever take a look at this project again in a year from now. And the last one is the presentation. Not only the presentation that you give in the end, but also the general shape of how your project looks like. If you give me a repository that is not ordered, doesn't contain a README and doesn't help me to find my way around there, you will get a few points deduced for that. So please also make sure that whatever you hand in is presentable, doesn't contain typos, those kind of things. This is the table by which I will grade you. You can come back to this slide later if you want to check where you are. And I will also, after each assignment, send you an email with the information of how many points you have for each assignment and in total, so you can already kind of estimate where you will land in the end. The 3 assignments for the project are as follows. The first one is initiate. So I will ask you to come up with a topic, do some research, gather some basic data, and understand what the goal of this project should be. So you should come up with a plan and also estimate how much effort it will actually be to pull off this project. The second one will be the big kind of part that you're probably also most excited about, which is the hacking part. You will, play around with the machine learning algorithm, run some trainings, try to optimize the parameters, the hyperparameters, play around with the architecture and improve as much as you can. However, bear in mind that time is limited here. So, I expect you to do a couple of optimizations, but just for your own information, don't expect that you will be able to do a lot of optimizations here. And the third part is the delivery. I would like you to take whatever you've achieved in the second assignment and package it nicely in a way that you can ship it, deploy it somewhere and run it and demonstrate to someone else what you've actually done. And the reason why I believe the third assignment is also really important is that it's nice if you managed to achieve and train a good model. But if you cannot show it to anyone what you've done, if you can't present your work, it can seem like a bit of a loss or a waste of time, because then people will not be interested, people will not understand potentially what you've achieved and how cool your project potentially is. A few words about the logistics. The entire course will be held online. There will be weekly topics that should be useful for your project. As I said before, I will try to upload these videos in advance that you can already consume them at your own pace. There will be weekly Zoom calls for your questions and answers. I encourage you to come to these calls, ask me questions about the lecture. So I will always kind of link it to a specific lecture that I ask you to watch this at that week. But of course, feel free to also ask me other questions about your project, etc. So this is your chance, to get in touch with me and ask questions. The final presentation will be a 5-minute video that I ask you to record. And in the last 2 lectures, we will watch them together online. So you will send those videos to me in advance. I will create a playlist and then we'll watch those 2 lectures, all of those videos. Please be aware that this is kind of a strict time limit because of the number of participants here and also a bit of a question and answers that we will have in between. So the last 2 lectures, please reserve the full 2 hours that we will be able to manage to watch all of the videos. There is kind of a limit of participants, and the reason for this is quite simple. I'm doing this lecture kind of as one person, and I want to look at all of your projects, give you personal feedback and understand and just not brush over your work, because you put a lot of effort in there and I want to reward that by giving you my attention and giving you advice on where to go. So if there are more than 25 interested students here, there is a waiting list, and please attend the first lecture, because some people always jump off, and we might be able to put a few more students into the course as I see fit then. But I also know from the last couple of years there are always more students than I can admit, and I'm sorry for that. You will have to come back next year. I will try to give this course again next year, and then you can take it. So don't be sad if you don't manage to get a seat, but please also don't give up too early, because as I said, you might be able to come in from the waiting list. And at this point, I also would like to appeal to you, to your fairness with respect to your colleagues. So if you're signing up, please follow through. Don't give up in the middle of the course, and only take this course if you really have the resources and you're willing to complete your project. Because, the seats are limited. So if you take the seat and then after the first assignment quit, another student who would have liked to take the course will not have the chance to take it. So just be fair to your colleagues and only sign up if you really have the time. My experience also tells me that you should consider 75 to 125 hours of work for the project, which is roughly the estimation of the ECTS, maybe a little bit more. But it's also something that people most of the time feel really excited, and that's why they invest a little bit more time in this lecture. There is also one more organizational thing here. There's a preceding course in TIST listed, the Deep Learning for Visual Computing course. I personally took this course. It's a very exciting course and I loved it. It goes really into depths of deep learning, especially within the domain of visual computing. And if you're asking yourself now, what is the difference between those 2 courses, is that course goes kind of into depth within one field, whereas the applied deep learning course tries to cover a broader field, but I'm just not able to then go into such great depth with all of those areas. However, there is at least a bit of overlap in the beginning where we both talk about general neural networks, backpropagation, etc. So if you like this course, I highly recommend to also take the deep learning course for visual computing either before or even afterwards. In my experience, they perfectly go well together. The project itself, I would like you to do on your own, because project work sometimes, especially at university, tends to be work that someone does something and the other person maybe just doesn't contribute that much. And I really want each and every one of you to get the most out of this course. So please do discuss with your colleagues, but work on the project itself on your own. There's one more limitation that I want to mention here, that actually you will have to bring your computing resources yourself. I do not have a server farm that I can offer you for training. However, there are a couple of great online offers that I can highly recommend if you have a computer that does not have a super strong graphics card. For example, you can use Google Colabs or Gradient, and also from AWS, from Amazon and Azure. There are some offers where you can run some of your machine learning notebooks and algorithms online in the cloud. Some of them are for free, some of them come at a like a free tier, and then if you want to do more, you eventually need to pay a few euros. This is the schedule for this semester. Please be aware of those 3 dates for the assignments. The deadlines here, the 24th of October for the first assignment, then shortly before Christmas on the 19th of December, the end of the assignment 2. I specifically said it there because I also want you to have the Christmas holidays and not spend too much time and work during your holidays. And in the end of January, shortly before the last 2 lectures, the deadline for the assignment number 3. That's all about the logistics, and without further ado, let's jump right into it.